We saw from the table that the period of rotation of the planets around the Sun is directly proportional to their speed and distance from the Sun. That is, while the planet Mercury, which is close to the Sun, completes its rotation around the Sun equal to 88 Earth days, the planet Neptune, which is farthest from the Sun, completes its rotation equal to 60225 Earth days. In the solar system, the planets are arranged in inverse proportion to each other according to their area, volume, and weight. The area, volume, and weight of the planets increase from the Sun to Mars. It decreases sharply on Mars. Jupiter, which comes after Mars, also increases sharply. It decreases in Saturn and Uranus, which follows Jupiter, and increases in Neptune, which follows it. In the solar system, there are millions of satellites and comets that are inversely proportional to each other. The sizes of satellites and comets vary from 10 meters to 100 kilometers. Besides these, there are dusty and innumerable small bodies in the solar system. These small bodies and dusts are connected to each other by the force of gravity. Planets with higher hardness in order of arrangement from the Sun belong to the terrestrial group. It is proportional. Thus, the planets in both the terrestrial and gaseous planets are different in their arrangement with respect to the Sun. Due to the hardness of the terrestrial planet, they are closer to the Sun. In this group, the first one has a hardness of 543 grams per cubic centimeter, and the first one has a hardness of 524 grams per cubic centimeter. It is in the second place with a hardness of 515 grams per cubic centimeter. The third is Mars with a hardness of 3,933. This inverse relationship continues in the gas body. From this table, we see that the gravitational force of the planets is equal to the weight of the planets. The gravity of heavy planets is high, the gravity of light planets is low. From this table, we can see that all planets have a magnetic field. However, there is almost no magnetic field on Earth, Venus, and Mars. The magnetic field on the gas body is so strong that this planet, the tail of the magnetic field, reaches the magnetic field of the other planet. According to the laws of physics, the temperature of the planets should be adjusted according to their distance from the Sun. That is, the temperature of the planets should be high in the part closest to the Sun, and the temperature should decrease as they move away from the Sun. Compliance with this law has been paid in parts, north and south of all planets. At the poles, the temperature is negative, that is, the temperature is low. On Mars, the average temperature is positive, that is, the average temperature is between positive 20 degrees Celsius and positive 70 degrees Celsius. On Mars, the average temperature is minus 63 degrees Celsius. In the gas body, the average temperature starts from positive temperature and decreases towards negative. For example, while the average temperature on Jupiter is positive 5,000 degrees Celsius, on Saturn it is positive 2,000 degrees Celsius. On Uranus it is negative 220 degrees Celsius. On Neptune it is negative 214 degrees Celsius. The high temperature on the Earth, starting from the Sun side, is positive 430 Celsius on Mercury, positive 480 Celsius on Venus, positive 58 Celsius on Earth. Mars is minus 5 Celsius. Among the gas planets, Jupiter, which is close to the Sun, has the highest temperature of plus 1,700 Celsius, Saturn plus 11,700 Celsius, Uranus minus 216 Celsius, and Neptune plus 300 Celsius. We can see from this table that the temperature of the planets does not depend much on the distance of the planets from the Sun. The temperature of the planets depends on the planets themselves, i.e. the composition of the planet and the internal energy of the planet. If we look at the arrangement of the satellites of the planets in this table, we will see that the satellites are arranged according to the area of the planets. These satellites are mainly gathered around the gas body. In this group, Jupiter, which has the largest area, has 79. Saturn, which has a smaller area, has 62. And then Uranus has 27. Neptune has 13 satellites. There are only 3 satellites in the Earth group. The planets belonging to the Earth group in the solar system are loud. The surface of these planets has been exposed to crater fire other than Earth. The crater fire on these planets started from the first moment after the new explosion, and continued until the solidification of the planets. It is difficult to say something about how long this solidification process of the planets takes. It can be said that the solidification process accelerated as the planet moved away from the Sun. The surface of the planets belonging to the gas group is 2 gas and 2 ice. The speed of rotation of the planets around their equator in the solar system is inversely proportional to the weight, volume, solidity, gravity, and magnetic field of the planets. But the speed of the planets in the gas group is directly proportional to their areas. Jupiter is the most active planet in the solar system. For example, while the Earth completes its rotation around its axis in 24 hours, Jupiter completes it in 9 hours and 50 minutes. The Carter fire of the planets on the Earth has calmed down after the complete calm in the galaxy. That is, after all the bodies have adjusted their place in the galaxy. This is what we see when we observe craters on planets. From this trace, we can see that the craters fell on the surface of the planet when the planet was not fully solidified. If the craters fell when the planet was fully solidified, the surface of the planet would be covered with large and deep depressions. The Earth was also exposed to strong crater fire. The craters on the Earth were canceled by the arrival of water. Perhaps the Earth never suffered a crater fire? We see from this table how different the atmospheres of the planets in the solar system are. It is the internal structure of the planet that makes this difference. The planets create an atmosphere suitable for this world around them according to their inner world. We see from this table that the geological composition of the internal structure of the planets is different from each other. This difference is ensured by the way of life of the planets in the solar system. Due to this difference, the properties, atmospheres, speed, gravity, magnetic field, temperature, movement of the planets in the solar system are completely different from each other. Even the composition of the material structure of Venus is not compatible with any planet in the solar system. In order to conduct my research about the universe, about our galaxy, and about the solar system, I have researched almost all the articles, scientific hypotheses, scientific thoughts, scientific works published on the internet by scientists engaged in modern astronomy. Modern scientists believe that our planet was formed from a big explosion 14 to 15 billion years ago. During this explosion, billions of galaxies were formed. Our galaxy has 200 billion sun-like stars. Modern scientists say that our galaxy was formed in a Big Bang 4.5 billion years ago, which created more than 200 billion sun-like stars and billions of other celestial bodies. What was the cause of this explosion? According to me, there was no such explosion. I have given the whole explanation above. Maybe our solar system was formed from the merger of 2 sun-like stars, not during the merger of galaxies. The planet Jupiter in the solar system can help to prove the idea that our solar system was formed from the merger of 2 stars. We know that Jupiter has shrunk 3-4 times in size, brightness, and energy compared to the time of his birth. Jupiter's chemical composition is very close to that of the Sun. Therefore, there is a high possibility that Jupiter was a star like the Sun at the time of its formation. Perhaps Jupiter is the remnant of the core of a weak star at the time of the merger of 2 stars. Jupiter, which was bright when it was created, has lost its brightness over millions of years, distributing its energy. When I studied the solar system, I saw that the planets and satellites in this system are similar to each other in terms of their nature, composition, and energy source. If these bodies were formed from the disintegration of one large body, then these bodies should be very similar to each other. These similarities do not exist in the bodies in the solar system, so these bodies did not separate from a mother body perhaps. These bodies were placed in the solar system by interference. I am most interested in the Earth we live on. What is Earth? What is Earth? The Earth is the most beautiful. In a word, paradise in the solar system. In the language of scientists, this planet is not a celestial planet. The planet is home to 9 million species. The most beautiful, the best, the most conscious of living beings is man. Whatever the planet has, a person solves everything for his own benefit, at the expense of his consciousness, as if the planet was created for humans. The majority of people living on Earth do not know whether there is such a place of residence in our galaxy or universe. Those who know prefer to remain silent. Earth is protected by the planets in the solar system. For example, Mercury and Venus, which are on the sun side of the Earth, are hot planets. These warm planets help to maintain a warm, temperate climate on Earth. The planet that came after the Earth was Mars. He is cold in nature. Its highest temperature is -5 degrees Celsius, due to which a layer of cold air is formed in the Earth's atmosphere. Due to the cold layer, the water that sustains the life of living organisms does not evaporate from the Earth. Jupiter, the 5th planet after Mars, and Saturn, the 6th planet, are the biggest protectors of the Earth. Due to these planets, the solar system does not allow any of the free objects in our galaxy, or perhaps in the universe, to fall to the Earth. Those planets keep out all free objects in the galaxy and the solar system that could harm the Earth. Those planets keep in their orbit by attracting every object that freely roams in the solar system and wants to come towards the Earth due to the force of gravity. And when it is unable to attract it, it explodes or pushes it away from the Earth. The planets do not release even the smallest objects, even dusty ones, into the Earth. 141 large satellites, millions of small satellites, and millions of tons of dusty objects around these planets, which protect the Earth like the apple of an eye, have united in their orbit. Perhaps if there were no planets, or if there were planets of small size instead of them, there would be neither the Earth nor the celestial planet. After these two planets are the icy Uranus and Neptune. What is the role of ice planets in the family of planets that maintain the average temperature of the Earth, protect the cold layer, and protect it from foreign objects? According to me, these two gray planets are the cooling of the gas molecules that freely circulate in the solar system, preventing them from heating up and creating the thermocore. It seems to me that these planets play the role of a cooler in the solar system. From the research we conducted above, we can come to the conclusion that the Earth and the planets around it are not concentrated around the Sun by chance. Planets clustered around the Sun were created by alien planets at artificial speeds. These alien planets have created a new habitat for living organism, or rather humans, with the help of alien planets in the solar system. But how did the Earth, which was created with the help of the planets, and the living organism on it? In order to study the Earth, let's first study its crust. The Earth, like other planets, became an ember after a big explosion 12-13 billion years ago. I have no idea how many cycles the cooling process takes. According to me, the Earth cooled in the following stage. First, a part of the upper layer of the new globe cooled to a certain thickness. After the peeling process of the upper layer was completed, the subsequent peeling process was created thanks to the volcanoes. Gases formed due to Earth's activity at the bottom of the newly formed crust create pressure at the bottom of the crust. Thanks to the pressure, the gases in the 6 parts of the new crust find their way through the Earth's crust to the upper layer. Together with these gases, a large volume of lava is formed in the upper layer of the Earth.